Hey, Science 10. So today we're going to cover lesson 1.2 from your notes package on bond formation. Just some notes for today. We'll look into any kind of assignment from this next day, but do take these notes. It's for your learning. You guys are going to need to know this down the road. So I'm going to have to walk you through some of this because some of it does relate back to Science 9 topics that you might need a reminder about. So let's start with this. There's two sections in the notes that you need to have information about. Here's the first one. So I asked you to kind of make a diagram or outline using board diagrams about what a chemical reaction looks like that makes an ionic compound. Remember, an ionic compound is a compound that's formed from ions. Ions are atoms that have an electrical charge. Some atoms, when they get an electrical charge, they get positive because they give up electrons. Some get negative because they take on more electrons. Protons are positives, electrons are negative. If you've got the same number of the two, your charge is 0. Here's an example reaction. I'm going to show it to you. This is a magnesium atom. Here's an oxygen atom. But how do I know that? What I've made here are called board diagrams. It's a Science 9 topic. You may remember, and this is an important thing to remember, that atoms, of course, have a nucleus. The nucleus has protons and neutrons. Orbiting the atoms are the much smaller electrons. Those electrons orbit the atoms in shells. The shells have set capacity for electrons. The shells can be full or they cannot be full, but they have a capacity and you can't go beyond that capacity. The first shell has space for 2 electrons. This is a magnesium atom, so we've got the Mg symbol in the middle. 1, 2. Its first shell is full because the shells are always filled from the inside going out. Now, an atom of magnesium has got, let me think, 12 electrons. Here, we're filling it this way. The first shell gets 2. The second shell is full when it's given 8. 10 so far, and then 1, 2. And that third shell makes for 12 electrons. That outer shell, the third shell in this case, is called the valence shell. This is where all the action happens. In a chemical reaction, chemical reactions involve electrons being shared or electrons being given away, taken. They all involve the valence electrons. So the valence electrons are super important when it comes to chemical reactions. Here we're making an ionic substance. So electrons are going to be given by one atom, taken by another. Let's look at oxygen. The O here just means oxygen nucleus, 8 protons and 8 neutrons. It follows the same rules as you see for magnesium. The inner shell, that first shell, is full at 2, and it fills first. The second shell, well, we need 8 electrons in total, so only 6 more after these 2. 1, 2, 3, 4, 5, 6. They're filled in like pairs like this. Pair, 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 and then lone electrons right here. It's those lone electrons that make oxygen reactive. It's these lone electrons here that make magnesium reactive. And in a reaction, magnesium is going to give it up, oxygen is going to take them. Because for atoms, they tend to react, when they're making ions, they tend to react in a way to have an outer shell that is full. Here's what that reaction looks like. Magnesium atom, the plus means it's in a reaction with an oxygen atom. This arrow here means it makes, it creates. This is all, you'll see this in your textbook reading, by the way. Please do it. This stuff right here, magnesium oxide. We made an ionic compound. You know the naming rules, but maybe you're getting a bit of a better insight into what this stuff is. It's a compound where you've taken magnesium, you've made it into an ion by stripping away 2 electrons. You're taking oxygen, you've made it into an ion by getting 2 new electrons that came from the magnesium. The magnesium has a positive 2 charge. Look at this. Its valence shell, its outer shell is now full. The oxygen is now called oxide. It has 2 electrons that have been given to it. Here, I'm putting them in red. That's why I haven't added them yet. Here, hope you can see that. That is a red circle. I'm just putting that there to show you, hey, that electron came from magnesium, and so did this one right here. The oxide has a full outer shell, 8 electrons. In other words, 10 electrons in all, because it's oxide. It's not oxygen, it's oxide. It has 2 more electrons than it has protons. There's a lot to unpack here, I know. But this is a Bohr diagram that shows magnesium oxide. This part right here, the magnesium ion. Magnesium with 2 in the middle, 2 in the first shell, then 8. It's had 2 stripped from it, and so it's got overall a +2 charge. The oxide, not oxygen atom anymore, the oxide has been given these 2 electrons right here, so it's got a -2 charge. The whole packet, the compound, is called magnesium oxide. That's a reaction that has created an ionic compound from 2 pure elements. Now, I'm going to run you through a different kind of reaction, and that is this one right here. We're making water. You can pause the video right there, and I'll walk back to the stand for it. What's happening there? Here, this is a hydrogen atom, or excuse me, it's a hydrogen molecule. It's H2, it's got 2 hydrogen atoms, and they're joined together because they're sharing an electron each. This is the way the hydrogen's got its shell full as a pure element by each atom sharing its electrons. Notice I marked them in red right here. Like that. This is oxygen, just like before. 8 electrons in total, it has as an atom. Smart cookies among you are going to know that oxygen is the same as hydrogen, that it goes as O2 and the atoms go in pairs. But I'm not worrying about that right now. The plus there means that they're combining. The arrow means making this stuff. And this is what gets made. You might think, oh, what's that? H and O and H, bunch of Bohr diagrams. Well, the answer is that it's water. It's H2O. H2O. This is where your subscripts start to make actually a lot of sense. Look at this. H2. Hey, look. 2 hydrogens. O. Just 1 oxygen atom. But the other thing I want you to notice is, and this is probably the most important insight in the whole lesson, is that right there. Between the H and the O, 1 red, 1 black circle, little dot or whatever. That is a covalent bond. That is a covalent bond, meaning that electrons are being shared between that hydrogen atom and the oxygen atom next to it. And then it's the same on the other side of the molecule. That's the structure of water. Key thing to remember here is there's no square brackets, right? Because water is not an ionic compound. It's covalent. The electrons are being shared by the oxygen and by the hydrogen together. It's not an equal sharing, and that's a different topic of conversation, but they are being shared. Versus, for the magnesium oxide, they weren't being shared. They're transferred from the magnesium, making a magnesium ion, to the oxygen, making an oxide ion. I'm going to show you what this looks like, because that's a bit more exciting. Here it is. Striker. I would have you guys do this if you were here. tongs, striker, Bunsen burner. Bunsen burner has a covalent compound coming out of it. It's called methane. Every methane molecule's got one carbon atom and 4 hydrogen atoms. There's energy in those bonds. Great thing about this, about you guys being distance, is that you can look at this directly because the UV light doesn't get made by your computer. There's no more magnesium here. I could try and see if I can get anything else out of it. It's actually kind of cool. What I do see here is that it's red hot. You might not be able to see that super well where you are. But I've made a substance that has different chemical properties. Here, let me show you that they're different. Take a piece of magnesium metal, you put it in water, it's just going to sit there because it's a metal. This new compound we've made, magnesium oxide, that's going to dissolve in water. In fact, this works really well because you can see actually that there's a little bit of magnesium metal that didn't burn because it was under the clamp, and then it sunk to the bottom. So you can see, whereas the rest of it is slowly disappearing in the solution. All right. I'll demonstrate that for you again. One of the most important reactions in human society, in not such a good way, is the formation of rust. Rust is iron oxide. We like to have things that we can use for our daily lives that are mostly made of iron. Problem with iron is that it corrodes, it rusts. It has a natural tendency to make iron oxide. And this explains why you never find pure iron in nature, with the exception of in meteorites that hit the ground and land on ice or whatever. Yeah, you'll find pure iron there, and ancient people use that stuff. Or find the same thing happen in the desert. Otherwise, you dig a hole in the ground, you're not going to find pure iron because iron reacts with the oxygen that's in the air. And before the oxygen was in the atmosphere, there was plenty of elemental iron around. But a layer of rust in the fossil layer tells us oxygen appeared and all the iron rusted. This here, this powder, this black powder, is elemental iron. It's probably got a little bit of layer of corrosion on it, but it's close enough. There. The ingredients in that reaction were the iron filings, which are free of charge, which are from the chemical cabinet, and the oxygen, which was free of charge. It's already in the atmosphere thanks to plants. That's the formation of iron oxide. And of course, I could do a bar diagram for it, but we'd be here all day because Oxygen is a much bigger atom. That's all the learning pieces I want you to get from today's lesson. I hope it was useful. I'll continue from lesson 1.2 next week and probably have an assignment for you then. Bye for now. Have a good weekend.